sharing any links. Yes?
Are your PowerPoints going to be up on course site?
Yes, and they're actually already up. Remember, there's a website, csc2.lehigh.edu. So actually, this was at the very end of class last time, so just have a look here. All the lectures are here, including future lectures. These will change over time because these are just links to Google Sheets. So if I change a lecture, that change is immediately reflected in these links, so you don't need to worry about versions. There are labs here as well for each of several semesters. I will be updating this at some point, but these are example labs for those of you who want to get more experience. Now remember how I said you guys are acquiring a skill here, and acquiring that skill is dependent on practice, just like after you learn to snowboard, you need to practice going down different hills. This is the same deal. So you can use these labs to practice. The same thing is true for homework. There's homework for many semesters. There will be homework for more semesters. Use these homeworks to practice if you've already finished your homework. Because I guarantee you, you'll find the exams harder than the homework. And to get a good scope of what actually will be on exams, how difficult exams are, do these old exams. There are answers available for these exams, but they're not posted on the website. I will email them to you at some point before the actual exam, answers for old exams, and you can use them then, but try to answer these questions on your own. If I haven't sent the exam answers back, that shouldn't stop you from starting to do these answers, to do these exams, because you will know if you got the answer correct or not. And you should be able to implement, you should actually be able to take the code that you write and actually run it and check to see if you solved that question. So all that stuff is there if you need it. You can find that all on this website. There will be a course site for this page. The course site will actually link to the stuff for this semester. Note that this is all old material. The course site will link you to this semester's labs, homeworks, and exams. And for example, when we go to the lab on Friday, we will log in the course site and do the first lab. Now I realize that course site's not up yet. I haven't put it up yet because of other things going on, but it will be up by Friday so that you'll have access to it. All of your grades will be accessible via course site, and they will be delayed a little bit based on when you've submitted whatever it is that you need to get a grade for, but it'll be up on course site. Any other questions? Good. I'm glad to see that many people are logged in. Okay, so today we need to talk a little bit more about how exactly programming languages work and what exactly the system that you'll be working with is. So I think that most of you have experience with computers using either Mac OS or Windows of some flavor. And the reason why most colleges teach software development in the context of a different operating system, like some variation of Unix, is because Unix is the original inspiration for Mac and Windows. And for that reason, it has characteristics that are common to Mac and Windows, characteristics that are preserved even though Mac and Windows sort of branched away from Unix decades ago. So that means that there are characteristics of Unix that are guaranteed in Unix and also guaranteed in Mac and Windows that are not, that you might not be immediately aware of because these are things exposed to programs and not necessarily to human interfaces. So you're going to be learning a little bit of Unix in order to do this class. Learning a new operating system is never easy, and that's because it's annoying. You have to figure out how to redo the things that you already knew how to do. But you don't have to do that much with it. It's not like you're going to be trapped in the Unix operating system for the rest of your life. This is just a way of getting things done. And just to give you some scope on this, I didn't start learning I didn't start using computers on Unix either. I started with I guess a predecessor of Mac OS, but then I was using Windows most of my life. I use almost exclusively Windows now. I treat Unix as a tool to help me get some things done, and otherwise I don't really touch it. I don't surf the web in Unix. I don't have a laptop that runs Unix. I don't have a desktop that runs Unix. I simply log into Unix machines because Unix helps me get a lot of work done. And in fact, that's a distinguishing characteristic between Mac and Windows and Unix, because Mac and Windows have these nice interfaces that are designed for people who aren't really programmers, whereas Unix is designed for what you could say are enterprise efforts. So people who are trying to get large-scale software done, people who are trying to run things on a very big scale and run things dependably. That makes Unix sort of a working operating system, whereas Windows and Mac are kind of a pleasure operating system, or a consumer operating system, if you want to think of it that way. So those distinctions will carry through, and we'll see that. But I want you to understand that just because Unix exists as an operating system doesn't mean that it's your whole life. It's just another way of getting things done. Just as if you owned a Windows computer and a Mac computer, you might use the Windows computer for some things, the Mac computer for other things.
Are Unix and like Linux the same thing?
Unix and Linux are relatives of each other, and you can think of Linux as a more recent offshoot of Unix. In fact, there are many flavors of Unix, and Linux can be said to be one flavor of Unix. Please always interrupt with questions, because if you have a question, then that means that other people here have a question that they're too shy about. So always interrupt with questions. Okay, so because Unix is an operating system, even though it's really foreign, I want to remind you, even before you start using it, that you need to just try stuff. So if you're mostly a Windows user and you once used somebody's Mac, or if you're mostly a Mac user and you once used somebody's Windows machine, you know that like you can click around and try things and try to figure out how to get things working. It should be the same thing with Unix. Now Unix is going to be awkward and strange, but that doesn't mean you can't just try things. You can't break the computer, you can't do anything irreversible in the environment that you're exposed to, so you need to just try things in order to learn. Okay, so a little bit more background. What exactly is an operating system? The operating system is software that's running on a computer so that the background processes of the computer are taken care of so that you can get things done. So a computer has to take care of itself. It has to do all sorts of things that you don't want to worry about. It has to manage your files. It has to monitor the network. It has to send things off on the network and receive things on the network and give them to you later. It has to manage its memory to make sure that it isn't running out of things to remember, and it has to move memory around to make space for other programs you want to run. It's sort of like if you had a personal assistant, that personal assistant is taking care of things that you don't have time to take care of, so you can be more efficient. The same thing is true for an operating system. And that is true for Windows, Mac, and Unix. The difference is that Unix may be a little bit more focused on industrial or sort of enterprise efforts. So it's a little bit more specialized for things that people who want to run large-scale things want to do. So if you want to have a computer that serves a web page to tens of millions of people, then you definitely are running a Unix system and not a Windows system, because the Unix system is maybe better at multitasking, better at monitoring the network for many, many different connections, better at operating its disk than Windows is. On the other hand, if you want to play video games, if you want to watch videos, maybe Windows is better because Windows maintains the most up-to-date codecs for the different kinds of video you can have, and maybe has the best drivers for video cards and this sort of thing. So there are reasons why we use different operating systems for different purposes, and the primary difference between what you've seen so far, sort of consumer operating systems, and enterprise operating systems like Unix, is that basically you haven't had a need for running enterprise stuff. But the other reason why we teach Unix is simply because Unix has characteristics that are conserved in all operating systems, and it's a great way to learn it. So one of the big differences between Unix and Windows and Mac is that Unix, although it has a graphical user interface, is very focused on a text-based interface called the terminal. The terminal is literally a command line. It's a place where you can type commands in. And this system responds to your commands by giving you text back. The reason why the terminal exists, especially in these enterprise systems, is because the terminal gives you ways of specifying things in a very detailed way. It has much more expressiveness than the clicks of a mouse do, and so on and so on. So rather than clicking through some wizard which is going to give you different options, you can type things into the terminal, and people have found that this works better. In particular, if you want to automate the commands that you want to run, if you want to have the same command run many times, if you want variations of the same command to be generated and then run, the terminal is very expressive for this because it's very good at things like substituting words for other words so that you have variations of commands that run for you. And this is how the Unix terminal finds its niche. So you guys will be seeing the Unix terminal on Friday. You'll follow a bunch of commands for logging you into an account. And the first thing you'll see basically will be that Unix terminal. So the most important command to know on that terminal is a command called man. And everybody makes comments about misogyny in tech, and it's easy to joke about here, but man is short for manual. And what man does is it simply tells you what any command in Unix does. So that's really important because you will frequently hear about commands in Unix that you don't know how they work. When you start talking to other people who have maybe done a little programming before or know some tricks that you don't know, as I encourage you to do, people will tell you about, oh yeah, just use grep, just use ls, just use cd. They'll tell you about these commands and you'll be like, whoa, what was that again? Why is that command called cd? Like, what does it do exactly? Rather than having them sort of explain all the details, and there are a lot of details, man can simply pull up the manual for that command and tell you how to use it. In fact, tell you in more detail than you might even want to know. But that makes things easier because you don't have to wait for somebody to reply to your email, or you don't have to wait for somebody to reply to your text. You can just ask the computer. Okay, so after you know the command man, the most important command to be aware of is ls. ls is short for list, and it tells you what files are in a current directory. Now, this is not obvious with the command line here, but just like Windows and Mac maintain hierarchies of folders, where you have folders inside folders inside folders, where there are files in those folders as well as other folders. Unix has that also. In fact, Unix is what originated the idea of having hierarchies of folders. And at any given time, your terminal is associated with some folder. So even in this page here, in this screen here, I'm actually looking at the contents of the folder, or I'm residing inside of a folder. So one of the things I might want to know is, tell me what files are in this folder. And that's what ls does. So when I run the command ls, this tells me that I have 3 files, test1, test2, and test3, and a subfolder called testdir. Now, just be aware in terms of nomenclature that a directory is another name for a folder. And the reason why that is sort of historical. At some point, Steve Jobs decided he hated the word directory and just called them folders. And now they're called folders by a lot of people. So I will use them interchangeably, and I expect you to also. So the files here are just words, and the directories are distinguished because they end in a slash. And that's why I know that testdir is a folder and not a file. So the other thing that you can use ls for is that ls has a number of commands that it accepts, a number of variations in which you can use it. So one of the things that you can do is that you can give ls a directory to have ls tell you what are the contents of some other folder, right? Because I don't want to always look at the same folder all the time. I might want to look at the contents of some other folder. I can look at what's inside this folder testdir, and lo and behold, I have 3 other files that happen to be called test1, test2, and test3. I cannot have files in the same folder that have the same name. And you guys are probably aware of that issue in Windows and Mac also. You just can't have files with the same names, otherwise they'd be considered the same file. So inside this folder tester, I have other files that have the same name, but that's okay because they're inside a different folder. Yes?
So if you did ls test1, it would open that folder?
Test1 is not a folder. Tester is the only folder that's visible. So
because it ends in a slash.
that's right. So test1 is a file. There's two files called test1, one that's inside the outside folder and one that's inside the tester folder. And there's only one obvious folder here called tester. Do not be afraid to ask questions. So just to give you an example of man, if you want to know the many other options that you have for running ls, you can type man ls, and it will tell you how to sort files in a certain order, tell you when they were last changed. It will tell you how you can identify file sizes, who owns a folder. It can answer all sorts of questions that you have about particular files so that you can get things done that you want to get done. Yes?
If you're doing the ls with the directory as an input, does that directory need to be inside the current directory like it is in this case, or could it be any directory out?
That's a great question, and let me hold off on the answer to that because I can give you a more general answer after we talk about some other concepts. And also, please say your name before you ask your question because I will eventually get your names. It just takes a little bit of time. What was your name?
Sammy?
Sammy. Okay. Yes.
I'm Katie. What do you
Nice to
mean
meet you,
by
Katie.
who owns it? Like,
So a file has many properties, one of which is who owns that file. So when you have files that are owned by somebody, the permissions for changing that file, even accessing that file, or even seeing that file are controlled by that person. So when a person owns a file, then they're the ones who can change the properties of that file. And they can make it so that everybody can change the file or make it so that nobody can change the file. That dictates who can interact with that file. You also have people like administrators, super users, who can say, modify anything in the computer just because it's their job to make sure the computer works. And sometimes, if somebody's making a file that they need access to, then the administrator can look into that file, even if the person said, well, nobody can read it. So there's different levels of access. These are called permissions. And part of the permission system is implemented by somebody owning a file. Yes?
All right, I'm Claudia.
Nice to meet you, Claudia.
Yeah, nice to meet you. Okay, so for this, when you're like typing this in, where exactly are you typing this into, like for all these commands?
Well, on the simplest case, you would actually have a screen that's black, and you just have lines of text on it.
Okay.
There's no window or anything like that.
So how do you, that's like, isn't that when your computer like restarts?
That's exactly like when your computer restarts.
Okay, so you would just type in these, with this black screen, and like that's what, like all of these lists, I guess, will come up or whatever when you're doing.
When you type in the commands, yes.
Okay, and how do you get to that list or whatever to be able to use this, I guess?
So you will be using a slightly artificial variation of this. So in the simplest case, if you were to, in fact, when you set up Unix, many Unices do not even have a graphical user interface to begin with. You have to set that up. So when you first started up a fresh install of some Unix, you will just see the black screen with a terminal that's like, all right, what's your command? So on many modern Unixes, which have been criticized for not having graphical user interfaces and just being more user-friendly, they have a user interface that's graphical, and they have a window that's just a black screen that has the things in it. And you guys will actually be using a variation on that where you will have a web page that inside the web page there's a frame in the web page where you can write your commands. But it will work the same way because it'll be like, all right, well, you're in this folder, like what commands do you want to run?
Thank you.
Great question, Claudia. Okay. The second command you need to be aware of is cd. And just for reference, I realize that you might feel that some of these things don't seem like programming things. This stuff is on the exam. CD stands for change directory. So remember how I said that when you open the terminal, you are looking at a folder, even if you haven't listed the contents of that folder. What changing the directory does is it changes the location of the current working directory into some other directory. So if I was in the CSE 308 folder, which I was in the previous example, if I say cd tester, that's going to change my working directory to tester. So when I type ls, I'm going to have these files in it, test1, test2, test3. And that literally changes my viewpoint from the one folder to the other folder. It's sort of like if you double-clicked on a folder in Windows or Mac, and the view of that folder changed from the old folder into the new folder. CD is really useful because not only can I change directories from the current folder that I'm in to a folder that is contained in my current folder, but I can actually change folders from my current folder to any folder at all that I have access to. So, for example, if I want to change to some folder that is in a different directory tree or in a different branch of my directory tree, I could type something like cd/home/username and change to some other location. So suppose my username was Chen, then if I wanted to change to my home directory, and everybody will have a home directory that's like this, it'll be cd/home/Chen, and that would move to that home directory. Now, this concept is really important because the name and location of folders is really important to keep track of, and you'll use that quite a bit. So it's important to understand that what this is here, this assembly of folder names where it's like /home/username/CSE308/tester or whatever, that list of directories, that's called a path. And the reason why it's called a path is because it's a path from sort of the root directory, the directory that contains all directories, through a set of folders into a particular folder that you're looking for. So if I was curious about this folder Karen, then if I wanted to change directories from whatever directory I was in, suppose I was in /user, the path that I would specify to CD, the command I would use with CD would be cd space /home/Pete/Karen. Because I'm basically specifying the folders inside the folders that I want to go to. And if I want to change, I don't have to change from Karen to Susan. I can change from /home/Pete/Susan to /bin in one step. All I need to say is cd/bin. That moves me to that different part of the tree, even if there's multiple steps in the tree to get there. And the way that's possible is that we have this addressing system, this way of identifying folders inside the tree simply by listing the nesting pattern of the folders inside that tree. Yes?
I'm Patrice, and...
Therese or Treese?
Patrice.
Oh, Patrice.
Yeah. This is probably a silly question, but...
There are no silly questions.
Do you include the little carrots when you type, like, the username, or just...
Oh, that's a really good question, and thank you for being so specific. The carrots are just my trying to indicate that this is kind of an ambiguous field, and you wouldn't type that in.
Okay.
Yeah, that really good clarification, Patrice. Yes.
I'm Will. So is the / used to specify absolute versus relative file paths for change directory?
I'll get to absolute versus relative in a second. Yes.
So it's pretty much like /home/whatever you go to. Is that pretty much like when you open a folder in Windows and then like open like my file, like you open your files and you just keep going down and down like the folder? Is that pretty much what it is, but in Unix or whatever?
Yes, that's exactly how it is. So it's sort of like if you open Explorer in Windows, you just start clicking on folders. And in fact, you may have noticed that in Windows shows you the path of the current folder that you're in. That Windows path is inherited from the Unix thinking of storing things in paths also. What was your name?
Greg, I don't know.
Greg?
Yeah.
Okay. Yes.
My name's Hannah. Can you like go to the next slide really quick? Oh wait.
This is one I haven't talked
Yeah,
about.
this one. So say you're in like the Joe one, so to get there originally you would have to do like home/Pete/Joe. But then if you're in the Joe and you want to go to like Steve Pete? Do you have to redo the whole thing, or can you just say to Steve, since you're already in the Pete folder?
That's a great question. So far, I have only told you about something called an absolute path. There's something called a relative path, which allows you to do that. Just give me 1 second and I will get to that.
Yes.
Yes.
My name's Amy. If we go back 2 slides, so how come for the third yellow command, how come there's no slash before cast?
That's a great question that also has to do with absolute and relative paths. Right.
So do you just pretty much have to know where you want to go if you want to like do your paths, because you can't like see? Can you see like the where you want to go, or do you have to like know like that you want to go to project and then CSC3 or?
So you do have to do some exploring using LS and CD in order to find what the structure of everything is. There's nothing that will sort of draw out the whole tree. Well, there are things that will draw out the whole tree, but we're not talking about them. So with the tools that I've described so far, yes, in theory, if you were presented with a huge tree, you'd have to like walk through it and type LS and look at what the contents are and sort of get an idea of what the layout is. But there are more advanced tools that would sort of help you map it out if you would. Okay, so since there's a lot of questions on absolute paths, I'm going to tell you about PWD in a second, but it'll help explaining that in a second. So you'll notice that I specified locations in that directory tree by using slashes, right? And you'll notice that I mentioned that we start with a slash. Like locations are /home, /Pete, /Karen. So the reason we start with a slash is to indicate an absolute path. An absolute path is a location in the directory tree relative to the home directory, the slash directory. So in fact, if you ever want to change directories to the home directory, you can type cd space /, and that gets you back to that root directory. So, but if I want to change just like I've already forgotten. Just like somebody asked, if I wanted to change from one folder to an adjacent folder, how exactly would I do that if I didn't want to type in the entire absolute path? The way that you can do that is by using these shortcuts and by not putting a slash in the beginning. So notice that the first time we changed folders from the current directory into tester, a folder that was contained inside the current folder. Like if I was changing from Pete to Joe here. The way I would change that folder would be cd Joe. Not /Joe, just cd Joe. And that's because I'm using a relative path there. So it's sort of like saying, change this folder that I see right here. I can use relative paths to change to a whole bunch of different places. Like if I was in the home folder and I wanted to change from, if I wanted to change from the home folder to Karen, I could say cd Pete /Karen, and that would move me into this folder here. But that prevented me from having to type in the absolute path, which was cd /home /Pete /Karen, which saved me some typing. And in cases where you have very complicated structures of data, that could save you a lot of typing, because sometimes you have a lot of folders containing the one folder that you want to change to, and the change that you want to make is actually a minor thing at the end of the path. Right.
Yeah. So how do you explain how you went to home to Karen in the shortcut right again?
Yeah, so if I was already in home and I wanted to change to Karen, I would type cd Pete /Karen. Note that I wouldn't type in cd /home /Pete /Karen. That would be the absolute path. The relative path that I would use would be the location of Karen relative to my current location. That's what makes it a relative path. So that would be cd Pete /Karen. And what makes it not an absolute path is the fact that I haven't started with a slash. Yes?
It's Hannah, but so you can only use that if they're connected. Like if you wanted to go from USR to Karen, like you would have to type the whole thing, because it's not like in the line.
That's right.
Yeah.
It
Okay.
would only be if they're connected, except that I'm going to show you a shortcut that will connect everything. So that's right. From what you've seen so far, it's only if they're connected. But let's expand on that a little bit. So there's a shortcut that's called dot dot. So just like when you guys are looking at a directory tree, and you want to move up in the directory tree, it's usually like a picture of a folder with the arrow that's going up. The same thing is true in Unix. In fact, Unix sort of originated this idea, take me to the containing folder of this folder. So how do I go to that containing folder? I would say cd dot dot. Cd dot dot just always is step back to whatever the containing folder is. And if you just typed cd dot dot slash dot dot, that would be like take me to the containing folder that contains my containing folder. cd dot dot slash dot dot. So in fact, I could step out several directories just by saying cd dot dot slash dot dot slash dot dot slash dot dot slash dot. And that means that using the dot dot, using the double dots, I can move up and down the directory tree with a relative path. So if I wanted to change, if I was in directory user and I wanted to change to directory Karen without using an absolute path, I could say cd dot dot slash home slash p slash Karen, and that would move me to Karen using a relative path. Or if I was in Joe and I wanted to switch to Karen, I could say cd dot dot slash Karen, and that takes me to the containing folder and then back out to the Karen folder. And in both of those cases, I've avoided using an absolute path. Yes?
So if you say you're in the Karen folder and you wanted to, I don't know what I'm trying to say. If you were in a folder already, do you have to back out of everything first, or is there like a case where it's sometimes just easier to use a direct? Like, can you?
Yeah.
You know what I
No,
mean?
that's a great question. So should I use an absolute path or should I use a relative path based on where I am and where I want to go to? So your decision to do that is based on what's easier to type in this case. Because if you want to go to a very close folder, maybe it's just easier to type dot dot since it's just two key presses. But maybe if the thing that you want to go to is like many containing folders away, maybe it's just better to just be like cd slash whatever. Or maybe you just happen to remember it that way as opposed to typing dot dot slash dot dot. Because it's just what you're typing in to help yourself, it doesn't really matter which one you choose, but having both absolute and relative paths sort of gives you those two different trees. There are other questions.
I'm Suresh.
Suresh?
Yeah.
Suresh.
Yeah. I was gonna say, is there any benefit to using an absolute path? Because I feel like it just narrows down your choices of
That's a great question. So the question is there a benefit to using an absolute path? The answer is that right now there's no obvious benefit. Now, outside of this class in the future, one of the things that you will do, one of the things that lots of software does, is you have software that is automatically referencing different folders and moving things around, retrieving data, and many times that software is operating on folders that were named by a user. So like, maybe that software always goes and, I don't know, moves files that start with a certain letter into a different folder. And it's always in a folder name specified by the user. So sometimes you have like these variable names for the files, and you just know that this is a folder contained by whatever it is that the user specified. So sometimes it's easier to just be like, all right, just go to the containing folder and go to the one that I want to go to. So you would actually say blah, 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 slash, dot, dot, slash, blah, file name. Other times it's easier to do the absolute because you don't want to, you already know where it should go and you don't have to fill in sort of changing file names. So there are conditions in which the absolute is better than relative. There are other conditions in which relative is better than absolute. But in this class, the benefits of them are not huge. I just want you to be aware of them because, you know, if you are interviewing for an internship and they're like, well, write me a relative path, which is like one of the simplest things you can do, and you don't really know what that is, that would certainly save that. Yes,
I'm Delaney.
Delaney?
Can you repeat how to go from user to Karen using a relative path?
Yes, so if I wanted to go to user, from user to Karen, I would say cd dot dot slash home slash Pete slash Karen. And that's a relative path because I'm not starting with a slash, but also because I'm stepping back out into the root directory, out, and then back up to Karen.
Slash home slash Karen, you said?
Yes, it would be cd dot dot, cd space dot dot slash home slash Pete slash Karen.
Oh, slash.
I mean, a better example might be if I was changing from sysop to Karen. Then it would be cd dot dot slash home. I'm sorry, cd dot dot slash Pete slash Karen. Okay. Good.
And
Amy.
what would be the absolute path for that?
For Karen, the absolute path for Karen would be slash home slash Pete slash Karen. Good. Okay, so we've learned about how paths are laid out in the following way. Basically slash name, slash name, slash name, slash name. And we know that relative paths never start with a slash. The absolute path always starts with a slash because the absolute path specifies locations from the root directory. The relative path specifies locations based on where you currently are, the current working directory. Okay, something else that you'll have to do is to copy and move files. So to copy a file, we say cp source destination. So if I wanted to copy, say, this clustlew file into a new file called clustlew2, then I could say cp clustlew space clustlew2. And what that simply does is it makes a copy of that old file with a new file. And note also that you can make copies of files specified through a path. So if I wanted to copy clustlew and it was in some other folder, then I could say cp dot dot slash my folder slash temp slash clustlew space clustlew2. And that would copy clustlew from some other folder specified by that relative path to, in the current folder, clustlew2. So all that's doing is taking a path to one file and a path to the other file and saying, take that file and make a copy of it in this second location. The command move is a variation of the command path, and the only difference is that the original file is deleted. So the original file is not there anymore, and the destination file is the only place where it exists afterwards. Okay, so one thing that you'll need to do as you make homeworks, as you make labs and such, is that you'll always need to make a new folder for each one of your homeworks and labs. So you'll need to make and delete directories. So when you make a directory, the command is mkdir, make directory, and you just give a path to that directory. So that includes the location of that directory plus the new name of that folder that you're going to give that directory. So if I was making this command, if I was making this folder Joe, then I would say mk, and I was in the slash, the root directory, then I would say mkdir slash home slash Pete slash Joe, and that would make me the Joe folder. And if I wanted to use a relative path, and I was going to say sysop, I could say mkdir dot dot slash Pete slash Joe. That would make me a new folder called Joe in this location. Yes?
Hey, my name is Caleb. When we're moving and copying files, when you say like the source is a path to wherever, and like the source and destination commands, do we just have to put the original, like where that file is located and where we want to move it, or the actual paths to the current file and the path to the destination?
It has to be the path to the source file and the path to the destination. Now, if those files are in the same folder, then you're still actually providing a path. It's just that the path is trivial and there is nothing to write. So what it always was a path to the source, the path to the destination. It's just that you don't have to write anything if it's the same folder. Yes?
My name's Olivia, and can you, once you created a directory, like, next slide. Yeah, once you've made a directory, can you put stuff directly in that, can you put stuff directly in that directory? Like, can you go into the file and then make something new inside of the file rather than having to copy and move it?
Yes, so once you've made that folder, you can put things directly into that folder.
Like, you can open a blank, whatever, and
Folder.
then put it directly into that folder. You don't have to take it from the original and then put it into a folder.
That's right, that's right.
Okay.
So are you referring to a new path, a new file, excuse me, and not a new folder?
Okay, so like if you're creating a Word document and then you want to save your Word document, when you open all of your files, you can literally put it right into the file. You don't
Yes,
have to,
yes, you will be able to put it, you will be able to save that Word document right into the new folder.
Okay.
And in fact, that's one thing that will come up. Like you'll make a new folder for your lab, and then you're going to make your first lab, helloworld.java, and you're going to save it into that lab folder. So that's exactly something that we'll be doing. So another important command is rmdir, and that's how you remove a folder. And it's important to know that rmdir removes only empty folders. And the reason why that's the case is because usually when you want to remove a folder, you want to be really careful about removing a folder, because sometimes you don't mean to remove that folder, but there could be a lot of data in that folder and you don't want to delete it by accident. So that's why rmdir is there, and it has a name that's very similar to mkdir. Now, if you want to remove a folder that has things in it, there's a special command, rm-r, which will remove everything that's inside that folder. Just be careful, because Unix is sort of designed for people who know what they're doing, it's designed for experts, that you could remove a lot of stuff all at once. And maybe you want that. You know, maybe you want to remove a whole tree of folders because, hey, you were just testing out mkdir, right? So rmdir is there, but just be aware that you can remove a lot of stuff using that. Now, if you use rm-r on something that was important and that sort of messes up your user, then we can fix it. Don't worry about that. But just be aware that like aggressively removing everything might leave you in some inconvenience. Did you have a question?
Well, I was just going to ask if there was like a undo command that I could use after this.
Yes, that's a great question. In the most traditional versions of Unix, there is no undo command. Now, in more recent versions of Unix that have something called a journaling file system, that file system actually keeps snapshots of your files at certain times of the day. So like the most aggressive journaling file system save a copy of your files every 15 minutes. And you can actually go to a secret folder to say like, oh, give me that old version. I deleted that thing that I didn't need to delete. And you can copy it all back out. So it's like you would actually copy everything from the secret folder back into the original folder, allowing you to restore everything that you had. That doesn't exist in what you guys will be using, but generally you'll have another way of restoring what you have, and we'll talk about that later. You'll learn about that on Friday, because the way that you guys can restore things that you delete by accident will be by retrieving it from a versioning system called Bitbucket, which is very similar to GitHub, which some of you have heard of is sort of the place where a lot of people leave their open source software so that other people can use it and share it. And having a Bitbucket or GitHub account is really important to your development as a software developer. Okay, so excuse me, this is an old slide. We will not be using Dr. Java. You'll be using instead something called Cloud9. So Cloud9 is a web-based programming environment. I can type in my password. Cloud9 is a web-based programming environment where you can open up a workspace. That workspace is just a place where everything is stored. And inside that workspace, you have access to a Unix terminal, and you have access to a file editor that can change programming files for you as you run your code. I haven't touched Cloud9 in a summer, so it's sort of like digging it out of cold storage, so I'm sorry about that. If it's Azure change, it's storing data from Hibernation. But it's going to basically give you a terminal, and it's going to give you a place where you can change your files, and you will run your code in Cloud9. And when you are done running your code and you want to save it, or if you want to submit it submit your homework for collection, you will take your code and you will commit it to Bitbucket. Now, what is Bitbucket? It's not just a storage place. Bitbucket is storing versions of your code. So just like I said, like the most sophisticated journaling file system save copies of your folders, the most sophisticated software developers out there save copies or versions of their code to something called a version control system. And what that does is it remembers the new versions of your code as you save them, so you can get them if you need them. But more importantly, it integrates changes that multiple programmers make. Because actually, the sort of pop culture picture of what programmers do is not single programmers working by themselves. It's very large teams of programmers working together. That means editing other people's code, reading other people's code, and having your code modified by other people. And the way that happens is not by people emailing versions of their code to each other and trying to keep that all straight. That would be a disaster. The way that this is kept straight is that there's a single piece of software called version control, which takes a check-in for your modifications, and it basically keeps score of all the changes. So it's like, oh, you modified line 5, all right, add that in there. Then the next check-in comes in and it's a modification of line 10, well, it adds it in there. Somebody else deleted line 5, well, okay, remove that. It keeps a centralized picture of what the current version is, and also all the previous versions from all the check-ins. So you will use version control through Bitbucket. And Bitbucket works exactly the same as GitHub, except that Bitbucket has privacy for, because this is a class. So let me zoom in out a bit. You can see a picture of my folders in CSC2. You will be creating things like Lab 1 and some other stuff. You can see me testing out code for exams. And this is your terminal. So you'll be editing things in the terminal. All right, so we didn't get through all the slides here. Make sure that you look at the other slides in this talk, because they're also on the exam.